Hello everyone, I hope you are doing well. So in today's video, I'm actually going to make I'm going to walk through the 2021 Maths Methods Exam 1 for the Northern Hemisphere. So yeah, let's get started. Okay, I've not touched this paper, by the way. This is quite new to me. This paper, I've not touched it, so I'm quite not certain what questions I'll have. I might get some questions wrong. If you guys see any questions wrong, please make sure to put in a link, put in the comments. I'll have a look at it and see what I've done wrong. Okay, perfect. Let's start. Question 1. Find the derivative of this. So, okay, this is the question rule. So if we let u equal this, and this is v, so we can say u is equal to e2x, v is equal to 2x plus 1. U dash is equal to 2e 2x. V dash is equal to 2. Now, we know that the product rule, so like dy dx is equal to, okay, it's equal to 2e 2x, 2x plus 1, minus 2e 2x, all over v squared, so it will be 2x squared. 2x squared, so 2x plus 1 squared. Okay, can we simplify this? Yes. So if we say dy dx is equal, if we take a common factor of te2x, it'll become 2x plus 1 minus 1 all over 2x plus 1 squared, which means that dy dx is equal to 2e2x, it'll become 4xe2x all over 2x plus 1 squared. I hope that's right. Alright, that's it. So let f, be this. So f sine, sine to the power 4, this. Okay, evaluate f dash and sub pi of 4. Okay, 2 marks. So f dash of x is, think of writing this as sine 2x, sine 2x squared. So bring that 2 in the front, derive the inside, so cos 2x. Again, write the outside one, and minus, it's supposed to be 4 here, and minus 1, so it'll be 3. Is that right? So we, alright, what did I do? I don't know. It's supposed to be a 4 here. What did I do? So, okay. There's supposed to be a 4. Okay. What I do, so I bought the food for, find the derivative. Okay, perfect. So, f dash pi on 4 is what? So it'll be 4. So when's cosine pi on 2? So if I draw the cosine here, it's pi on 2 at actual 0. So think of this as pretty much 0, being all multiplied by 0. Like 2 pi, there's no need to work that all out because it just should equal to 0. So we can say f pi on 4 actually equals to 0. Okay, hope that's right. Done. So let h be this. Show that h dash of is that. Okay, so if that's u and that's v, so we can say that h dash of x is actually equal to x to the power 3 multiplied by 1 over x plus log e 2x multiplied by x to the, so x squared. What am I doing? 2x squared. Wait. Okay, u dash is 3x squared. Anyway, yep. So that's that, and that simplifies to x squared plus log e. I'll just bring that 3x over here. Anyway, 3x squared log e 2x. Now, this to show, it's the same as the equation, so we can h of dash of x is 3x squared log e 2x plus x squared. We've shown that. Okay, perfect. Let dy dx equal this. The graph of y passes through the point this. Find the rule of y. Okay, so if we integrate, this dy dx. So we know y. Okay, so if we integrate this dy dx, it'll be 3x squared log e 2x dx. Okay, now we can actually integrate a log. So, well, yeah, in methods. So what way we can do it? We actually use integration by recognition here. If you look at the last question, we know that if we know that h dash of x is actually equal to 3x squared log e 2x plus x squared, we only want this part over here, if you really look at it. So we can say that h dash of x minus x squared is 3x squared log e 2x. Perfect. That's what we actually need. So we can actually just sub that in. We can just sub this in over in our equation. So we can just rewrite this as the integral of h dash of x minus x squared dx. Alright, we know that the integral of h of x is just h dash of x is h of x, so it's just going to be box square, so x to the power 3 log e 2x minus x to the power 3 over 3, okay, plus c. Now, we know that there's this point that exists, so let's put that to find c. So, if we sub that in, we're saying 1/8 log e 1 minus 1/8 divided by 3, which is just 8, 16, 24, so 1 over 24. It's going to be written as 1 over 24. Plus c, it's all equal to negative 25 over 24. Now, that log e1 is just 0, so we can say negative 1 over 24 plus c equals negative 25 24. So c, your value, is 1 minus 25 over 24, which is negative 1. Yep, looks right. So your final answer, if I just make this all small and nice, so then we just take this, put it over here. Your final answer should be y equals x, so it'll be sure x to the power 3 log e 2x minus x to the power 3 over 3 minus 1. Okay, that's your answer. Perfect. Move on to the next question. Yuck, probability. Okay, Steffi is raising money for her school with a lucky dip game. In this game, 100 identical cubes, numbered from 1 to 100, are placed in a large container. The container is then roughly shaken. A player pays $2 and is blindfolded so they cannot see. The player then selects a cube at random. Okay. If the number on the selected cube is a multiple of 10, which is 10, 20, 30, okay, to 100, the player wins a cash prize of $7. Okay. The cube is then returned to the container, which is for shaken again. Before the next makes a random selection, each selection is independent, so straight away binomial distribution. Just from that independent word, and yeah. So, what I would do here is find the probability that a player will win a cash prize of this. Okay, for a player to win a cash prize of $7, we know that for him to win $7, he has to get a multiple of 10. So, there's only pretty much 10 multiples out of 100, because there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So there's 10 out of the full 100. So 10 out of the full 100. So that's 1 over 10. That's not too bad. Yep. What is the expected loss to a player per game? So we want the expected value here. Okay. Let's really think about this. Let's say, wow, okay, wait. What is the expected loss to a player per game? Wait. So if I draw so let's say that say if he actually, there's only two outcomes. He loses or he wins, by the way. This is the two outcomes. So if we just draw a nice, okay, think about it. If we just draw two nice columns over here. Like that. And so this is your probability, actually this is your just x, and this is your probability of x equals the small x. Okay, so he loses, he's gonna lose $2, so it's gonna be -2. If he wins, he actually doesn't get $7. He pretty much wins $5 because he spends those $2 to even get in the game. So we'll say +5. Now, we know that the probability of actual winning is this over here. So we can say that this is 1 over 10. So this should be 9 over 10. Now, we know that the expected value, so expected value of x is equal to -2, 9 over 10, plus 5, 1 over 10, which is -9 over 5 plus half. If I said this -18 plus 5 over 10, 5, okay, so that'll be 10. So 5 minus thing, it's 8, 9, 10, 11, 12, 13, 13. So -13 over 10, which is equal to, well, we'll leave it as a fraction anyway. That's, yeah, just leave it as a fraction. So that's your answer, -13 over 10. Is that right? -13 over 10. So yes, actually it makes sense, because the expected value, let's say you're playing this game, it means that you are expected, if you just randomly play this game, you are expected to fail, because it's a negative number. It means you lose. Yeah. That's the truth about this game. Yeah, so the expected loss, okay, looks right. Let P is a random variable that represents the proportion of one by a player in random samples of 3 games played. Then what's this? Okay, well, we know that P hat is equal to x over n. Now, our n value is what? 3 here. So we're saying 3, what's 3 times 2 over 3? So 3 times 3 is just 2. So this can be written as, what is finding the probability of x is equal to 2? And now we can actually use binomial distribution. Okay, we know there is only 3 games he plays, so we can say that there'll be 3 choose, and we want to get 2. So probably success was 1 over 10, yeah? So 1 over 10 of winning. 2. Probably of unsuccess is 9 over 10. 1. So, if I'm not mistaken, this is going to be 2, 3, 3, 1. Okay, 0, 1, 2, so it'll be 3, 1, 100. Yeah, 10 squared is 100. 9 over 10, which gives us 982. So it'll be 27 over 1,000. Okay, that is... yeah, that's that. Is that right? Is that right? So, I'm going to pull random samples of 20 games. Okay. Yeah, it looks right. Okay. Okay, next question. Let F be this and G be this. find fg of x in the form of this. Okay, not bad. So we know f is what? This, so it'll be fg of x is 2e log e x plus 2 plus 1, which is 2x plus 2 plus 1, which is 2x plus 4 plus 1. So therefore your final answer is of fg of x is 2x plus 5. Okay, looks right. Next question. State the range of fg of x. Okay, the range is, well, it's a straight line anyway. So if we really look at it, if I draw here, it's a straight line that goes through 5 and it's positive. So it goes like this. It goes like that. Okay. Now what we know is that the domain of this function is the domain of the inner function, which is g of x. Now what's the domain of g of x? It's from -2 to infinity. So let's say this is -2 over here. So, and it is a open circle and it goes to infinity. What is the range now? The range is, if I sub in -2 to the equation, so what's 2, -2 plus 5, that's 1. 2 times 2, 4, -4, okay, 1. So this point is 1. Oh, well, it's supposed to be over here, but let's just put it over 1 in the negative x's, who cares? Because, yeah, 1, and it goes to infinity, yeah. So your range of fg of x is from 1 not included to infinity not included. All right, I'm just going to rub this off. I don't want them to look at that. Okay, that's it. Let t be this, so, and let the graph of the function h be the transformation of the graph of the function g under t. So, okay, and we know that h equals f inverse. All right, so what we want to do is the g over here, the function g, which is log ex, okay, this, so let's get, put this, so g of x, let's write it here, so g of x log e x plus 2. Now, what we want to do is really expand that matrices out, so it'll be x dash equals x plus c, y dash equals y plus d. So it means that x dash minus c, y equals y dash minus d. Now putting that all in the equation, we get y dash minus d equals log e. Your x here is x is x minus c plus 2. Okay, we get this. So your y, your new y, is log e x dash minus c plus 2 plus d. And we know that h of x, so h of x is the inverse, so let's find the inverse of f of x. So let's find the inverse. I'm just going to make this smaller. I feel like there's going to be a lot of working out. Okay, I'm going to put this right over here. And just draw a line over here. Okay. Okay, so let's find the inverse of f of x. So let f of x equal y, and interchange y and x. Interchange y and x. Okay, so that means it's x equals 2ey, so 2ey plus 1. Okay, so plus 1. So it means that x minus 1 over 2 is equal to ey. So your log e x minus 1 over 2 is equal to y. So all we need to look at is how can we get this equation, what values of c or d give us these two equations must equal. Alright, so well, there's a fraction then on like x over 2 on this one over here, but there's no one over here. So how? Because there's no actual dilation by a factor parallel to the x-axis, because nothing, it's just a translation C and D. Okay, so what they've done here, what have they done? What are they trying to do? Okay. So this thing over here can be written as log E as x minus 1 minus log E2 equals y. Yeah, so log E, yep. Ah, okay. This is okay. Yes, I see what they're okay, perfect. Alright, I see it. So now it looks like this over here, and your d value. So what can we say? The inside, which is negative c plus 2, must equal negative 1. So we can say that 2 plus 1 equals c. So c is actually equal to 3. And your d value here is just negative log e2x. No, not log e2. So your final answer, I'm just going to rewrite that nicely here. C is equal to 3. D is equal to negative log E2. Those are your answers. Yeah, that was actually, oh my god. It's easier when you see that. When you actually see that, using the probability rule over there. Okay, that's it. Part of the graph of this is given, s of x, blah, blah, blah. Okay. And we can see, yep. Let G, okay, so, let G from negative 1 to 2, okay, G of x, yep, so it's continuing the graph, and we just have to draw it. Not bad. So, that will make, okay, so it will likely be over here, because there's nothing's changed, so it'll be here. Where does it touch the y-axis? So if we put 0, it's just 1. Like that. And then it should touch here too. This one over should touch over here. Over here too. So, is that how it looks? Let's just put it all together. So, and now it's inclusive, because negative 1 to 2, so negative 1 to 2, now inclusive. So if I bring this over here, like that, and this one now is inclusive, because back in it was negative, they weren't inclusive, but now they're inclusive. Is that right? Is that nice? Do I need to draw any intercepts? Sketch the graph of G on the axis provided. Yeah, just sketch. There's nothing. Okay. Find the solutions to G of x equals 0. Okay, so negative 2 sine pi x plus 1 equals 0. So your sine pi x is half, actually. Yes, negative 1, okay, half. So when is sine positive? C-A-S, they're positive here. And our base angle is pi on 6. That's your base angle. So, and we're only going by this domain here. And we know, wait. So it's going from, so here, its x is between negative 1 to 2. So it'll be multiplied by pi, negative pi x, 2 pi. So it's going from negative pi to 2 pi. So, we will only have two solutions. So pi of x, it's actually equal to pi over 6 and pi minus pi over 6, which pi over 6x equals pi over 6, 5 pi over 6, and that means that x will equal 1 over 6 and 5 over 6. That's your answers. So that's that. Is that all? Okay. Find the area of the region bounded by the graph of G and the x-axis. So, where is it bounded? So, it's only bounded over here. Just right over here. The other ones, it's not bounded because if it was bounded, remember, the graph of G of x is just this yellow graph. If it was continued, like if it continued to over here, then we would take into consideration that. So yeah, we're just taking consideration of that little small area, which was actually easy because we know the x-intercepts, which are over here. We've already calculated. So we want to, because it's a negative area, we want to make sure we put a negative from 1 over 6 to 5 on 6 of g of x, which is negative 2 sine pi x plus 1 dx is equal to negative. Okay. Okay. So normally it'll be 2 pi cos pi x. Yep, it's because, okay, wait. It's negative 2. I'm putting negative, so that's 2. Okay, yep. Plus x, close bracket, 5 pi on 6, 1 over 6, which equals, so that's 2 pi over here, cos, okay, 5 pi over 6, so 5 pi over 6, we'll put over here, plus 5 over 6 minus 2 pi cos pi over 6 plus pi over plus 1 over 6. Okay, so simplifying this further. All right, think about it like this. Pi over, okay, so only signs pi, so it'll be negative cos pi over 6, and we know that pi over 6 is here, so 1 root 3, 2. So pi over 6 is root 3 on 2. So this can be simplified as root 3 2 pi root 3 on 2 2 pi root 3 on 2 plus 5 over 6 minus pi over 6 is again root 3 on 2. Yeah, pi over 6 is root 3 on 2. 2 pi root 3 on 2 plus 1 over 6. Okay, expanding this all. Okay, expanding this, so we'll get those two cancel out. So we're saying root 3 pi plus 5 over 6 minus, so these cancel out, so root 3 pi minus 1 over 6. Cancel, so okay, okay. These two cancel out nicely. Is that right? These two nice cancel. So it's 5 over 6 minus this. So it's 4 over 6. What? Whoa, wait. There's something wrong. How am I getting negative area? Have I done something wrong? Wait. Okay. Alright, I know what I did wrong. Okay. Just let me rub this whole thing off. Okay. I missed up one thing. I saw it. Alright. I need to be carefully do this. Okay. This is going to be, cos it'll be negative, so it'll be negative 2 pi cos pi over 6 root 3 over 6. Root 3 over 2, sorry. Plus 5 over 6. Okay. Minus. So, minus 2 pi root 3 on 2 plus 1 over 6. So, this will equal to, expanding, so negative root 3 pi plus 5 over 6 minus root 3 over pi minus 1 over 6, which will equal to, okay, this over here will negative 2 root 3 pi plus 4 over 6, which will equal to 2 root 3 pi plus 2 on 3. Is that your answer? Yes, it's positive, so I think that's that. Just let me write it as 6 root 3 plus 2 pi root 3 pi. Yep, I'm just going to write it like that. Like that, yeah. Is that right? Looks right, yeah. Okay, I'll just write units squared. Okay, next question. 6. Let A be events for a sample space such that probability of A this, given this, blah, blah. Okay, find the probability of B. Okay, knowing these here, let me just write this. So, I know that the probability of B given A is the probability of B intersecting A all over probability of A. So, well, I know this is going, here's 2 over 5. If we multiply, because we know probability of A is 2, 3, that will give us our probability of B intersection A. So that should be useful for 15. Probability of B intersection A. Okay, now we know that. What else do we need to know? Okay. So, let's look at the next one. So, this one over here. Saying that the probability of B given A is equal to the probability of B intersection A dash all over probability of A dash. Now the probability of A dash is just 1 minus that, so it's 1 3 here. 1 over 3. So we just change this to 1 over 3. And we know the other one's 1 over 4, so we 12. So 1 over 12 is equal to a probability of B intersecting A. Okay, so I think this should help. So if I'm going to draw a nice Venn diagram here. Okay, say, okay, we have 2 here. Very small. Okay, let me just draw bigger. Not the best, but yeah, AB. Now, we know that the B, this is this over here. So, that's useful. And we know that this over here is, if we put our hand on A, it's this over here. So, isn't it the addition of both of them? Because if we add both of them, we'll get probability of B, the full probability of B. So, it should be, so probability of B equals 4 over 15 plus 112. Is that right? Okay, yeah, so 12 times 4 is 48 plus 15 all over, so 15 times 12. 15, 12, so this will be 10, 2, 3, 5, 1, 0, 8, 1. So 180. So that would be 63 over 180. 63 1 over 180. Okay, so 63 1 over 180. That should be your answer. 63 over 180. That's that. Hope that's right. Let's go to the next question. Find the probability that A union B. What the hell? Okay, so what is that? Okay, A union B. So if I want to draw a nice, again, I want to just draw another probability Venn diagram over here. and so that's A and B. So what we're saying is A naught. So if we put our hand on A first, it means we just want this. And then we want union, so plus B naught. So if I put on B, so if I put my hand on B, we want this also. Okay, so okay, isn't it just... Isn't it just this over here? So 1 minus this. That gives us these over here. That's what we want to find. That over here. These squiggly places over there. Yeah, so it should be those probability of A naught union B naught is equal. Wait, is that right? So if I put my hand A naught, so for A naught, so B we want, and B naught that. Yeah, so it's equal to 1 minus, not 1, it's 1 minus the probability of intersection of B. 1 minus intersection of B, which is 4 over 15, which is equal to 15 minus 4 over 15, 11 over 15. I'm not too sure. Wait, probably of union B. It's just 4 minus that. Okay. Oh, wait. Oh, yeah, I messed up here too. So let's say everything 2. So normally you would, yeah, everything outside 2 must. Yeah, because, yeah, A naught. So if I put my hand on A here, B and so we want everything around it. From B, everything. So 1 minus, yeah, makes sense. Yeah, 1 minus the intersection gives us all that 1150. Yeah, looks right. Question 7. Let Q equal this and Q of X equal this. A rectangle ABCD is inscribed between the graph of the function Q and the x-axis. If vertices are A units where A is greater than 0 from the axis of symmetry x equals 2. Yep, as shown below. Okay. Find the value of A for when the rectangle is a square. Give your answer in this form. Would be it's an integer and C is a positive integer. So when it's a square, it means that this over here, this length over here, and this length must equal if it's a square. So this length, let's find this length first. So it's 2 plus A minus 2 minus A. 2 plus A minus 2 plus A, which is 2A. What about this length over here? This length is Q. Okay, so it's just Q 2 plus A, which is 2 plus A. 2 plus A 4 minus 2 plus A. Alright, so that will say 2 plus A 4 minus 2 minus A. 2 plus A 2 minus A, which is actually equal to 4 minus A squared. Because they're equal, so now we're going to equate them. So 2A is equal to 4 minus A squared. Bring the A squared here. Plus 2A minus 4 equals 0. I know for a form, it's in this form, it's not going to be a nice thing. So we're just going to use, I'm going to use a perfect square. Perfect, I think, yeah, not perfect, the turning point form. So A squared plus 2A plus 1 minus 1 minus 4 equals 0. So that will mean A plus 1 squared equals 5. Coming over here, so A plus 1 is equal to plus 1 negative root 5. A is negative 1 plus 1 negative root 5. Okay, but A must be positive. Yeah, A must be positive because, yeah, A must be positive. But A is greater than 0. So A must only be negative 1 plus root 5. And it just says, yeah, find the value, not values. So, yeah, that looks right. And makes sense, yeah. B is an integer, so it can be a negative and positive integer. Perfect. That looks right. So I'm just going to highlight this. Find the maximum area of the rectangle ABCD. Give your answer in this form. where n and p are positive all integers. Okay, so to find the area, so to find the area, we know here, over here, this is 2a, and this over here is what? Was it 4 minus a squared? And blah, 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 just did... wait, I need that. Multiply them together. Yeah, so now we multiply them together. So 2a, area. So it's in terms of a anyway. Yeah, a. So we can say area of a. So it's 2a 4 minus a squared. Is that right? Which is 8a minus 2a to the power of 3. So a dash of a is 8 6a squared. We know that a on this is equal to 0, which that means that 8 equals 6a squared. 8 over 6 equals a squared, plus or negative square root of 8 on 6 equals your value of a, which is just plus or negative 4 on 3 equals your a value, which is what? Plus or negative 2 root 3 equals your a value. But which a is it? Okay, wait. Well, we can actually just inscribe by just drawing it, because here it's like a cube. So if I just draw this, and I know that there's going to be an intercept at 0, and there's going to be two intercepts, negative 2 and 2, negative 2 and 2, and it's going to be a negative one. So it's going to start from here, going to go like this, and it's going to go like that. So when does the maximum area occur? It occurs here, which is from a must be between, a must be between 0 and 2 for maximum area, which means that a must equal to 2 root 3, not negative. Exclude that. So now we know that, we just have to solve it back into the equation. So a 2 root 3, so it's 4 root 3 here, 4 minus 4 third, okay, 4 root 3, for a 12 minus 4, 8 on 3, 16, 24, 32, so 32 through 3. Looks right. That's your maximum area. If I multiply both sides by root 3, rationalize it, that's 32 root 3 over 3 times 3, 9. Looks more nicer like this. And its area, so it would say units squared. Okay, that was good. So the graph of f is given here. Okay, it's this. And a part of graph of g is this. Okay, find f dash of x. So f dash of x is, wait, not f dash. So first, f of x is what? So let's expand it. So it's 2x minus x 3 on 2. So your f dash of x is much easier. So f dash of x would equal to 2 minus 3 on 2 x. So minus 1 will be half. So that's that. Let's simplify it, which is equal to 2 minus 3 root x over 2. That's that. So the tangent to the graph of f point B, this at the point, is perpendicular to the graph of G. Find the coordinates of B. So this is your G, and it means that somewhere around here, the tangent, so the tangent is right, this is, yeah, so it's perpendicular to the graph of G. Okay, so let's say we shove in B into the equation to find f. So what's f dash on B to find the gradient? So that's 2 minus 3 root B over 2. Oh, sorry. Over 2, so which is 4 minus 3 root b over 2. So that's your gradient, and we know that they are perpendicular. If we right now know this gradient, which is just 2, if we find the perpendicular gradient of g, so we know that the m here is 2, so, and we know that m perpendicular is negative half, we can equate them now, because now what we just did, we've just made this new g, we made g go like this. So yeah, we can equate 4 minus 3 b over 2 equals negative half, and that's equal to 4 minus 3 root b equals negative 1. So 5 is equal to 3 root b. Root b is actually equal to 513. So b must equal 2519. That's your thing. And if we shove it back into the equation f on b to get the y-intercept of it. So, but f of b, so it's 25, 9, 2 minus root, which is just 5 on 3. So 6, so 1, 3, so 25 on 9, 1 third equals 25 over 9, 18, 27, 27. So that means your coordinates of b is 25 over 9, 25, 27. This is your coordinate, yeah. Alright, looks right. So we can just highlight that. Okay. Show that the graph f and g intersect only at the origin. Okay. To do that, we can see, let them equal each other. So let's expand f of x first. Yeah, let's just expand it, which is what? It's here. 2x. So it's 2x minus x 3 on 2 is equal to 2x, which, okay, the 2x's cancel out. So it'll be negative x 3 on 2 equals 0. So x must equal 0. Okay, if we know that x equals 0 and we know that at g, if we put g on 0 is 0, yeah, this means that it just passes through the origin. This is the only point of intersection. Alright. G of 0, also f of 0, they all, yeah. Wow, okay. Let q be this, where q is greater than 0. Be the point on the graph g. The tangent to the graph of f at the point D passes through q as shown below. Okay. And it can be shown that D is actually... Okay, so 3 times this value of q gives us D, by the way. Okay, makes sense. Determine the value of values of q for which the tangent to the graph of f passes through q and has the x-intercept greater than 4. Alright, how do you do that? 2 marks. Okay, you can do it the long way, but it would have been like 3 marks anyway. Why would they put it 2 marks? So there has to be some trick they're trying to tell us to look at. Say, to make it greater than 4, so let's say this tangent's over here. Let's put this tangent over here. Yep, so if its tangent's over there, it will go and it's greater than 4. So yeah. And if we closely bring it, so the more we get closer here, we'll still get, oh, that's not nice, so like that. We still get greater than 4. But as we get close to 4, you can say as we get closer and closer to 4, like over here, yeah, then it just becomes a straight line. So it just cannot do that. So we can put the line everywhere over here, and it should actually, yeah, the tangent should be greater than 4, the x equal value. What about, say there's a maximum point here, I can see. Okay, so the tangent is just 0 at that point. And okay, so if this is over here and anything below it, so like over here, it gives us high greater than 4. Okay, so what does that mean? It means that if you really look at it like this over here, this turning point, everything on the right of it, so if we find the value, and everything on the right of it, every value of x here would give a tangent that is greater than 4, the x value greater than 4. What about when it's on the other side? So over here, let's put a tangent over here. All right, now it's a problem. See, now it's less. What about if we bring it closer? Less. Okay, so it's getting less now. Okay. So what does that mean? It means that if we know, okay, so the values exist from, let's say, this turning point and this 4 over here. This must be that. Let's just find the turning point of, all right, so what's the, if we go to f dash of x, which is this 2 minus 3 root, so f dash of x, 3, is it? Wait, is it 2 minus 3 root x? 2 minus 3 root x over 2, and we let that equal to 0. If we bring this forward here, so 4, 3 root x, multiply everything by 2, so 2 equals 0, 4, 3 root x, your x value is 16 on 9. Okay, so 16 on 9. So anything over here between these values over here will give us an x-intercept of greater than 4. So any three values of these. So, meaning that your d value must not equal them, by the way. Must not equal, because if it equals 4, it becomes a straight line like this, which, again, it equals to 4, and we want it to be greater than 4. And we cannot let it equal to 16 over 9 because it just gives a straight line, and it will never touch the x-axis. So they cannot touch. So from 16 on 9 to 4. Okay, but it says start the values of q. So, and we know q d is equal to 3q. So 16 on 9 is 3q 4. So meaning that we multiply everything by. So what does that mean? It means that we multiply everything by 1/3. So this would be 16, 19, 27. Oops, not equal. 4 on 3. Yeah, so that's your q value. Oh my god, for 2 marks, all of that for 2 marks. Yeah, that's a very ugly question. So yeah, just put it over here. That's your answer. Is that right? 16, 27? Yeah. And they cannot be equal. That's 2, okay. This is the last answer. Okay, this is the last. Wow, this exam is tiring. A differentiable function R has the following properties. F dash of x equals f of x equals this. Okay, this is an actual logistic equation. I've been doing this in my uni. Okay, the range of f is this, and find this. Okay. We can write this like f dash of x as just what? Y 4 minus y. And we know that the range of f is that. Okay, we want to find f dash of 0. So f dash of 0 is f of 0. Okay, sorry. 4 minus f of 0. And we know that f of 0 is 1. So 1, 4 minus 1, 3. That's true for that one. Determine the appropriate justifications of the number of stationary points of the graph of f. Okay, well, not too bad, because we have the f dash of x. If the f dash of x graph equals 0, like if touches the x-axis, it means we have some stationary points. Let's double check that. So f dash of x is here, and say, all right, we know that the range of f is this, so the range also must be just from that. So I have some ideas that it's probably here to here. That's your range of f. And also, wait. The range of f is 0 to 4. And that 0 is not included. It means it can never even touch 0. The graph can never touch 0. If you really think about it, the actual graph never touches 0. Because if it was, the range was from 0 to 4 with inclusive, so we can actually let it equal to 0, the f dash of x, then it makes sense. But if it's not equal to it, the range, so we can just say, we don't even need to draw a graph actually. We can just say, because the range of f is from 0 to 4. Yep, so 0 to 4. That's right, 0 to 4. And means that the actual derivative function must also be 0 to 4. Yeah, so because the range of f is that, is that right? If I find the derivative of that, wait. So I know, oh, it's such a confusing way. Because the range of f is that, I don't know how I would write this. Because the range of f is this, the f dash of x is greater than 0, which is true, greater, but not equal to 0. Wait, because the range of f is 0 to 4, the f dash of x is greater than 0, meaning that it can never equal 0, that it can never equal 0. Hence, no stationary points will exist. No stationary points. Stationary points will exist. So, determine the appropriate justification. So, stationary point, none. I don't know if that gives you the mark, but the range of f is from 0 to 4. We know that f dash of x is greater than 0. It makes sense. Okay. Okay. Let me just draw a graph. Let's just draw a graph. Let's just draw a nice graph. Okay. So we know so let's say if this is f dash of x, this is x, and okay. The range is from 0 to 4. Well, okay, let me just wait. I know for a fact I know for that a logistic equation looks like this. So it has two asymptotes at. From this one, it was y equals 4, y equals 0. And we know that when f dash of 0 is 3, so 3 is over here. It should look like something like that. Yeah, if that, and it makes sense, yeah, it can then touch 0 anyway. Because the range of f is from 0 to 4, the f dash of x is greater than 0, meaning that it can never equal 0, hence that no stationary points will exist. Yeah, there's an actual asymptote. Yeah, that's that. I think so, yeah. That should maybe give you the mark, not too sure. State the range of f dash of x. Okay, so okay, that's not bad. So just draw this. Because it's in terms of y, so f dash of x is this, y. So what it is it can be written as f dash of x is equal to y 4 minus y. So at 0, it has a y-intercept, and at 4, and it's a negative quadratic. So like this, like that. Okay. But we also know that the range is from, it's always like, it's greater, so it's just, we don't even include those here. So the range is from a k, oops, making sure that this, okay, so what's the point of maximum? So if we add the x-intercept, so we know that this is 4, 0, so add them together and divide them by 2, which gives us 2. So I'm subbing 2 into the function, so f on 2 is 2, 4 1 2, 2, which is 4. So we can say that the range of f, so range of f dash of x, of dash, is equal to 0 not included, 4 included. Is that right? So 4 is included, so 4 is here. 0 is not included because, yeah, from what we know, there's an asymptote of y equals 0. Wait, what am I, wait. Am I looking harder or am I looking different? Wait. Is 0 included here? Is 0 included? F dash of x. Well, that's just 0. Okay. I'm not too sure. Is that the right range? So from 0 to 4, but is 0 included? I'm not too sure, yeah. I think it is not included. But yeah. I have no idea. Wow. Yeah, I don't think it's included. Okay. No, okay. Oh, no. No, it is included. It is included. Okay. It is included, blah, blah, blah. Okay, just thought about it. Okay. It is included. I think so. Wait, I'm so unsure, but I think it is because here, this is a different, so y equals 0 and y equals 4 are your x-intercepts, so y equals 0 and y equals 4. And, yeah, that's range. Look. Okay, I'm gonna give I'm so unsure. I'm just gonna put, okay, not included, actually. 0, okay, not included. It just looks more right. 0 not included, but 4 is included. Okay, guys, thank you for watching. That was last question was a pain, but hope that's right. Yeah, have a good day, guys. Make sure to like and subscribe to this channel, and please share this video with your friends. If you guys want more videos, please comment down below, and yeah, have a good day. Bye-bye.